Radiation is energy traveling through space. It's like invisible waves or tiny particles moving really fast. We can't see it, smell it, or feel it, but it's all around us. Some radiation is natural, coming from the sun and rocks. Some radiation is made by people, like in X-ray machines. Understanding radiation is important for our health and safety. Too much radiation can be harmful, but we also use it in medicine and technology. Knowing about different kinds of radiation helps us use it safely and beneficially. Let's explore the fascinating world of alpha, beta, gamma, and neutron radiation. Alpha radiation is like tiny bullets made of 2 protons and 2 neutrons. Imagine them as tiny clusters of particles shooting out from unstable atoms. These particles are relatively heavy and slow-moving. Alpha radiation comes from things like uranium and radium, found naturally in rocks and soil. Because alpha particles are big and slow, they don't travel far, and can be stopped by a sheet of paper, or even your skin. However, if alpha-emitting materials get inside our bodies, they can be more harmful. An interesting fact, smoke detectors use a tiny amount of alpha radiation to detect smoke. It's safe and helps keep us safe from fires. Beta radiation is made of electrons, those tiny particles that zoom around atoms. Imagine them as tiny speedsters. They are much lighter than alpha particles and travel much faster. Beta radiation can come from natural sources like decaying plants and man-made sources like medical treatments. Beta particles can travel farther through the air than alpha particles and can penetrate skin a bit deeper. However, a thin sheet of aluminum or plastic can stop them. Interesting fact. Beta radiation is used to treat certain types of cancer. It targets and destroys cancer cells while minimizing damage to healthy tissues. Section 4. Gamma radiation energy waves from the atom's core. Gamma radiation is different from alpha and beta radiation. It's not made of particles but pure energy like light or radio waves, but with much higher energy. Imagine them as powerful waves of energy. Gamma rays come from the nucleus, the very center of an atom, when it's unstable and trying to become more stable. They're often released along with alpha or beta radiation. Gamma rays are very penetrating and can travel through thick materials like concrete and lead. This makes them useful in medical imaging, like X-rays, but also potentially dangerous if not handled properly. Interesting fact, did you know that gamma rays from space are studied by astronomers to learn about distant stars and galaxies? It's like getting a message from outer space. Section 5. Neutron radiation, the elusive particles of the atomic nucleus. Neutron radiation is made of neutrons, those neutral particles found in the atom's nucleus along with protons. Unlike other types of radiation, neutrons have no electric charge, making them harder to stop. Neutron radiation primarily comes from nuclear reactions, like those happening in nuclear power plants or during nuclear weapons testing. Neutrons can travel long distances through air and penetrate deeply into materials. Shielding against neutron radiation requires special materials like water or concrete. Interesting fact, neutron radiation is used to study the structure of materials. By bouncing neutrons off objects, scientists can learn about their atomic arrangement. Section 6. Radiation, understanding the invisible forces around us. From the tiniest atoms to the vastness of space, radiation is all around us. We've learned about alpha, beta, gamma, and neutron radiation, each with unique properties and uses. While radiation can be potentially harmful, it also plays vital roles in our lives, from medical treatments to generating electricity. Understanding the different types of radiation, their sources and effects, empowers us to use this powerful force safely and responsibly. By learning about radiation, we can appreciate its complexities and harness its potential for the betterment of humanity.